Welcome to the channel. Today we are going to talk about refraction of light. So what is refraction of light? Refraction of light is the phenomenon by which light bends when it moves from one medium to another. So why does light refracts? Because nature of the medium, light gets refracted. When light travels from homogeneous medium, it doesn't get refract. But when it travels from one medium to another medium, such as like an example, we can take water to air. Water is denser medium where air is rarer medium, so the light gets refracted when it travels from denser to rarer medium or rarer to denser medium. Now move toward some understanding of and effects of refraction of light in the light wave or light ray. Refraction decreases the velocity of light wave, and it also decreases or increases, so it changes its speed or velocity. It changes its wavelength, which is denoted by lambda. So as we know, the relation between wave velocity, wavelength, and frequency of the light wave, that or any wave, that relation between wavelength, frequency, which is denoted by small f, and wave velocity b is b equal to lambda into frequency. That means velocity of the wave is the product of wavelength and frequency of the wave. So the frequency of the wave doesn't get changed while rays are refracted, because frequency of the wave is locked in when it is formed after the oscillation, due to which it have to travel in different medium with the same number of crest and trough, so that it doesn't change or it is unchanged. So we can write frequency of wave is unchanged because it is locked in after oscillation, due to which it have to travel with the same number of complete waves in different medium. So it is unchanged. We have to only remember frequency of wave is unchanged during refraction of light. Now let's move toward some laws of refraction of light. So here, laws of refraction of light. There are two laws. The incident ray, refracted ray, and normal at the point of of the incident all lie in the same plane as refraction of light. The incident ray, refracted ray, and normal at the point all lie in the same plane of incidence. So, and second law states refractive index, or Snell's law. So Snell's law states that the ratio to the sine of angle of incidence to the sine of angle of refraction is constant for any two given media. So let's write it. The ratio to the sine of angle of incidence to the sine of angle of refraction is constant for two any given media or medium, which is also known as Snell's law. If I is the angle of incidence and R is the angle of refraction, then sine I by sine R equal to constant, as we discussed here. The ratio to the sine of angle of incidence to the sine of angle of refraction is constant, or and refractive index is denoted by n. So n from medium A to medium B with respect to medium A is equal to sine I by sine R. So it will be the formula for refractive index. Now there are some factors on which refractive index depends. Some factors on which refractive index depends, that are nature of medium, temperature of medium, and wavelength of light used. There are 7 visible spectrum of visible light. So they are violet, indigo, blue, green, yellow, orange, and red. It is the spectrum of visible light. So write nature of medium, temperature of medium, and wavelength or color of light used. We can obtain different colors of visual light by dispersing it with the help of prism. We will discuss about it further in another video. Now the seven visible colors are violet, indigo, blue, green, yellow, orange, and red. In short form, we can remember it as Vibgyor. So it is a spectrum of visible light. Now some conditions are there when light gets refracted from denser to rarer and rarer to denser medium, and how the wave reacts when it travels from these medium. Now let's discuss about that. When light ray travels from rarer to denser medium, uh, the wavelength and velocity of the light gets decreased. So, and it moves when and the refracted ray bends toward toward not yes toward the normal when it travels from rarer to denser medium. Now let's write it. When ray travels from rarer to denser medium, the wavelength and velocity of wave decreases, and the incident ray refracts to bend towards normal in denser medium. As an example, we can take we can suppose xy is a transparent interface between any two medium that are let the rectangular box be denser medium, and draw incidence ray coming from rarer, it will be rarer medium, coming from for clear and better understanding, make the ray more inclined to the interface. Now let's draw a normal perpendicular to the interface in 90 degree with the dotted lines. Here it is the normal. So when a wave travels from rarer to denser medium, it bends toward normal. As the actual refraction will be, the actual incidence ray will try to travel a straight line, but due to nature of the medium, it bends toward the normal. It bends toward normal, so it will be the angle of incidence and it is the angle of refraction. And as similar and opposite, when ray or wave travels from denser to rarer medium, the wavelength and velocity of wave increases and the incident ray refracts to bend away from the normal in rarer medium. When ray or wave travels from rarer to denser medium, the wavelength and velocity of wave increases and the incident ray refracts to bend towards bend away from the normal in rarer medium. As an example, draw the similar diagram. XY be the interface between transparent interface between any two media. Draw a normal perpendicular to the interface, and here a ray, incidence ray from denser medium passing to rarer medium will refract to bend away from the normal. It will bend away from the normal. It is normal. There it is normal. So it bends away from the normal, but the actual incident ray tries to travel in a straight line, and the angle of refraction is that, and angle of incidence is this. Now move toward another condition, the third condition. And the third condition is when incidence ray is perpendicular to the normal between any two interface, any two medium, it doesn't refracts. It travels in the straight line. So let's write it. When incidence ray is perpendicular or when incidence ray travels perpendicular with the normal, it doesn't gets refracted. So in any two medium, that let's take an example. XYB, the transparent interface between any two medium or media. XY, draw a normal perpendicular to the interface at 90 degree, and when incidence ray travels along the normal, it doesn't get refract. So the third condition tells that when incidence ray is perpendicular to any two media, it doesn't get refract, it travels along the normal. Now let's move toward another topic, which will be two factors in which refractive index is independent. We discussed before that the second law of refraction of light discuss about refractive index. So we have also discussed about the formula of refractive index and some factors in which refractive index is dependent. Now some factors in which refractive index is independent. That is angle of incidence and intensity of incident light. So what is intensity? As in simple words, the simple sentence, the average power produced the average power produced in per unit area is called intensity. As you know, its SI unit is watt per meter square from the definition. Okay. Now, what is refractive index according to wave theory of light? According to wave theory of light, refractive index of medium 2 or medium B with respect to medium A is defined as the ratio of velocity of light in medium 1 to the velocity of light in medium 2. So, according to wave theory of light, refractive index is refractive index of medium B with respect to medium A is defined as the ratio of velocity of medium A to the velocity of medium B, that is refractive index refractive index with respect to medium B refractive index of B with respect to medium A is equal to velocity of medium A by velocity of medium B, which is BA by BB. So velocity of wave is the product of lambda and frequency we discussed earlier, and if lambda A and lambda B is the wavelength of medium A and B respectively, then uh, refractive index of medium B with respect to medium A equal to velocity of medium A by velocity of medium B equal to lambda A into frequency by lambda B into frequency. As we know that frequency of the wave is unchanged during refraction, so it can be cancelled out, and remaining part are wavelength of medium A by wavelength of medium B, which can be also the formula for refractive index. So it will be equation 2, and the first equation we derived from the wave theory of light is equation 1. So now let's move toward another topic, absolute refractive index, which will be our last topic for today. Absolute refractive index. What does absolute refractive index means? The ratio of velocity of light in vacuum to the velocity of light in that medium is called absolute refractive index. Its value is always greater than equal to 1. So the ratio of velocity of light in vacuum to the velocity of light in that media is called absolute refractive index. It is denoted by simply n. So its value is always greater than equal to 1, and its formula will be absolute refractive index n is equal to speed of light in vacuum by speed of light in medium. So in physics we denote speed of light in vacuum as c and speed of light in medium as v. So it will be the formula for absolute refractive index. Why it is called as absolute? Because it contains the universal physical constant value of light. For that, it is also known as absolute refractive index. For today, that is enough. In another video, we will go and talk about different relation, real and apparent depth. For today, thank you for watching the video. Don't forget to like, share and subscribe. Hit the bell icon. Thank you.